Hello guys, can you now see my presentation?
Yes.
Yes po.
Okay. Hello and good day everyone, to our classmates and to Sir Frederick Ecija. I am Miss Gube together with Miss Costales, Mr. Dimaya, Miss Ilao, Mr. Wee, and Mr. Salamoding. I am so glad that we are here to discuss a very interesting topic today. Did you know that turbine engines may cause permanent damage to your ears? How loud is too loud? Did you also know that such small objects like nuts and bolts can cause serious injury? To start off and answer these questions, this is about the safety on the flight line, in which flight line is a high-risk environment or a place of dangerous activity. Let us, let us explain what hearing protection is and its essential. The extreme amount of energy released by turbine engines has made the flight line of a modern airport a high noise area. Continued exposure to this noise can permanently damage your ears and impair your hearing, meaning that the noise on a flight line comes from many places and aircraft are only one source of noise. Jet engines produce noise in different ways, but mainly it comes from the high-speed exhaust stream that leaves the nozzle at the rear of the engine. Planes are loudest when they move slowly, such as at takeoff or at landing. As the exhaust stream meets relatively still air, it creates tremendous shear that quickly becomes unstable. The turbulence produced from this instability becomes the roar of the engine. There are auxiliary power units or APUs, fuel while the bla- fuel while the blades are turning, chocks, baggage, handling equipment, and so forth. When combined all together, the noise on the ramp or flight line can cause hearing loss. Because of this, all personnel on the flight line, as well as those in the shop where the noise level is high, should wear some type of hearing protection. All personnel or maintenance technicians on the flight line must always be mindful of what is going on around them. It is recommended that workers shall be required to wear hearing protectors when engaged in work that exposes them to noise that equals or exceeds 85 decibels as an 8-hour total weight average or the average exposure to noise. This can be either external protectors similar to a pair of large earphones or internal protectors that fit into the auditory canal of the ear. Either types of Either types prevents sound energy from damaging the inner ear mechanism. The example of hearing protection is the image on the right side. Both types, external and internal protectors, reduce the sound level reaching the eardrum and reduce the chances of hearing loss. Hearing protection is really essential because working on a flight line with high frequency, even short-term exposure to these sounds can cause hearing loss. Continued exposure may result in hearing damage. To discuss about the noise, here is Mr. Salamoding.
How to look at noise. Intensity comparison with noise recommended permissible exposure time. 85 decibel is equals to 8 hours or 8 hours of exposure limit. 88 decibels are 4 hours exposure limit. 91 decibels are 2 hours exposure limit. 94 decibels are 1 hour exposure limit. 97 decibels are 30-minute exposure limit. 100 decibels are 15-minute exposure limit. So as you can see, the higher the decibels, the lower the time you should be exposed, or else further exposure on high decibel will cause permanently injury to the ear. Next. These are the types of uh, how loud is too loud. All sounds is measured in decibels and hearing damage can occur after exposure to noise of 85 decibels or louder. A weighted, de- a weighted decibels, abbreviated as dBA or dBA, are an expression of the relative loudness of sounds in air as perceived by the human ear. In a weighted system, the decibel values of sounds at low frequencies are reduced, compared with unweighted decibels in which no correction is made for audio frequencies. The decibels is a logarithmic unit used to measure sound level. It is also widely used in electronic signals and communication. The dB is a logarithmic way of describing a ratio, as you can see in the picture. Next.
Foreign object damage, or FOD, is if foreign objects such as nuts, bolts, and safety wires are drawn into an inlet of a turbine engine or through an arc of a rotating propeller blade, they can easily cause damage so that can lead to a catastrophic failure. And any object found in an appropriate location that as a result of being in that location can damage equipment or injured personnel. FOD includes a wide range of material including loose hardware, pavement fragments, catering supplies, building materials, racks, sands, piece of luggages, and even wildlife. FOD is found at terminal gates, cargoes, aprons, taxiways, runways, and run-up pads. The three main areas that require specific attentions are: first, runway FOD. This relates to various objects which is fallen from aircrafts or vehicle, broken ground equipment, birds, and etc. that are present in a runway that may adversely affect fast-moving aircraft during landing, takeoff and landing. Runway FOD has a greatest potential of causing damage. Next is the taxiway apron FOD. While this type of FOD may seem less harmful than the previous one, it should be noted that jet blast can easily move small objects into the runway. Last is the maintenance FOD. This relates to a various objects such as tools, materials, or small parts that used in maintenance activities, for example, aircraft maintenance and construction works, and can cause damage to the aircraft. The effects of FOD are the most notable being like damaging aircraft engines if ingested, cutting aircraft tires, lodging in aircraft mechanism preventing them from operating properly, and injuring people after being propelled by a jet blast or propulsion. The damage is estimated to cost the aerospace industry $4 billion a year. Next slide. The contributory factors that can affect the presence and handling of FOD are poor maintenance of building equipment and aircraft, inadequate staff training, pressure on staff not to delay movements for inspection, weather, presence of uncontrolled vehicles on the airfield. Defenses against FOD includes the following activities. Regular and frequent inspection of the airfield include aircraft maneuvering areas and adjacent open spaces, suspensions of runway operations upon notifications to ATC about FOD on or near the runway until FOD has been removed, and the runway inspected as necessary. Regular and frequent inspection of the airfield buildings and equipment, and immediate repair on withdraw from service of items likely to create FOD. Next is the inspection of the parking gate to ensure that it is free of FOD, including ground equipment, and of ice, snow, and other material capable of reducing braking action. It is normally the responsibility of the airline representatives. Next is the removal of FOD as soon as it is identified. Next is use of constant inspection systems, and lastly, it is implementing of FOD control program. Next slide. FOD prevention and clearance is the responsibility of all airport users. However, specific responsibility must be allocated to appropriate person who must be suitably trained and supervised. Quality assurance is an essential tool to ensure that responsible organizations and personnel carry out their allotted tasks correctly. While the airport authority is responsible for the runway, taxiways, and general maneuvering areas, airline representatives or handling agents are normally responsible for ensuring that the gate and its approaches are clear of FOD, including the ground equipment, and are free of ice, snow, and other contaminant capable of affecting braking action. Handling contracts must specify the extent of agents' responsibilities, and agents' procedures must specify how these responsibilities are to be exercised. Next.
Safety around helicopters. Helicopters are uniquely type of aircraft often operated in terrain in which an airplane could not be used. Personnel must often approach and depart from them when the engine is operating and the rotor is turning. The procedures and safety will be discussed by the next reporter.
Safety around helicopters. We have to understand that the passengers' familiarity and knowledge on how helicopters works depend on how we brief them, guide them, and have them understand on the danger it carries. One thing to keep in mind when working around helicopters is that many of the passengers carried on helicopters are not familiar with this type of aircraft. Therefore, it is your responsibility to watch that they do not endanger either themselves or the helicopter. This means that when a passenger are boarding in the helicopter, the pilot or the other crew members should advise passengers to stay away from the rear of the helicopter and crouch low before getting to and going under the main rotor. Next, please. Approach or leave machine in a crouching manner for extra clearance from main rotor. Approach or leave the downslope side to avoid main rotor. One way to enforce safety around helicopters is to have the passenger crouch down to avoid hitting the main rotor blade of the helicopter. This prevents damaging the aircraft and avoiding getting hurt by it. Also, the passenger should leave on the downslope side of the aircraft to avoid the main rotor blade. Next, please. Uh, Approach or leave in pilot's field of vision to avoid tail rotor. Next is to stay away from the pilot's field of vision because the pilots need to see when they are landing or taking off. This procedure helps you avoid getting hit or damaging the aircraft. Carry tools horizontally below waist level, never upright or over shoulder. Carrying tools are needed to be below waist level following horizontal position, which prevents from flying off from your belt to the rotor mast and damaging the aircraft. Next, please.
Hold on to hard hat when approaching or leaving machine unless chin straps are used. If the hat is strapless, hold the hat well to keep it from being blown away by the strong winds. Fasten seatbelt on entering helicopter and leave it buckled until pilot signals you to get out. Um, Fasten and adjust your seatbelt on entering the helicopter and leave it fastened until the pilot signals you to. Next, please. Leaving machine at hover get out and off in one smooth unhurried motion. If disembarking while the helicopter is hovering, get out slowly and smoothly when cleared to by the pilot. Do not do not touch bubble or anything moving parts like tail rotor leakage. Um, Keep landing pad clear of loose articles. Clear helipad of loose articles and secure your gear from the effects of rotor wash. Next, please. Loading assistants should always use plastic eye shields. After hooking up cargo sling, move forward and to side to signal pilot, and ensure the sling is not across the skid and never rise on the sling. Next, please. When directing machine for landing, to stand with back to wing and arms outstretched toward landing pad. When directing pilot by the radio, give no landing instructions that require acknowledgement, as pilot will have both hands busy. When directing the pilot by radio, remember they may be too busy to give a reply. Next, please.
An aircraft's lightweight construction, coupled with its airfoil-shaped wings and tail surfaces or rotors, makes it highly susceptible to damage from wind. So, an aircraft's all aircrafts are made from light materials for it to be able to fly. Next. Localized thunderstorms can occur throughout the year and appear in almost every part of the country. Regardless of the type of storm, damage can be severe for aircraft that are not protected. However, a great deal of this damage can be minimized if proper protective measures are taken. The best protective measure you can take to help ensure an aircraft's safety is to put it in a hangar. However, at times a hangar may not be available. If this is the case, an aircraft should be securely tied down and its controls firmly locked in place. Excuse me. In short, tie down, an aircraft tie down or picketing action is taken to minimize the possibility of movement of a parked, non-hangared aircraft due to high winds or propeller wash or jet efflux from taxiing aircraft. Tie-down is normally applicable only to smaller aircraft unless extreme conditions are expected. In this photo, this is an example of a tie-down of a light aircraft because light aircraft are most often secured with ropes tied only at the aircraft tie-down rings provided for securing purposes. Rope is never to be tied to a lift strut since this practice can bend a strut of the rope slips to a point where there is no slack. Since Manila rope shrinks when wet, about 1 inch of slack needs to be provided for movement. Too much slack, however, allows the aircraft to jerk against the ropes. Tie-down ropes put inverted flight stresses on the aircraft and many are not designed to take such loads. Thank you.